Hello, welcome. This is our first technical conference between BPCO and PANASIA. So, as you are aware, BPCO has been established in 2006, and we are operating from our headquarters in Halandri. And since June 2014, we have our office in London, and hopefully within September or June 2015, we will set up and will be in full operation our office in Cyprus. The annual turnover of our company was 32 million during 2014, and mainly comes from dry docks, marine underwater services, and afloat ship repairs. We have excluded all the PANASIA projects, since we have been appointed only on May 2014 as their main agents for the Greek market. We represent 38 companies exclusively in Greece, and the last agreement that we have signed was the Precision Control Systems in USA, which is a service station of Woodward, covering USA and the Caribbean. Within 2014, we have signed 14 exclusive contracts with Greek ship owners to cover all their ship repairs, dry docks, afloat works, and PANASIA systems. And hopefully within 2015, we will finalize 20 more contracts. As per our estimations, we will have an increase in our turnover 30 to 45%. One important announcement is that from September, we will have a new warehouse where we are going to store spare parts for PANASIA, so it will be quicker and more efficient the delivery of the parts on board. And also from June, we will have a service station in Greece with 2 service engineers. This will help PANASIA systems to be better and more flexible regarding their after-sales attendance. So today we are going to talk about the tank level systems, which is one of the products of PANASIA, and they are the main, let's say, maker in Korea and Japan. Then we are going to talk for SOx and DNOx systems, latest rules and regulations, and also latest technologies. And then we will come to the water ballast systems and the retrofit issues, rules, regulations, and whatever is concerned. Today we have with us Mr. Danny Lee, who is the Senior Marketing Manager of PANASIA. We have Mr. George Zhang, who is the Marketing Manager of PANASIA. And we have Mr. Ko, who is the Technical Manager of PANASIA, so you can address to him all your concerns. And also we have the pleasure to have with us Mr. Andreas Kokotos, who is partner of Argonavis Consultants. I would like to thank you, and let's say a good welcome to Mr. Danny Lee. Thank you.
Good evening. How are you, everyone? It's very nice to meeting you. My name is Danny Lee. As introduced, I'm a Senior Marketing Manager of PANASIA, and Greece is the most important territory to me. So I love Greece, a lovely country, lovely people here. So today, I talk about our activities. So a little late, so I'll just make it shorter of our PANASIA introduction and tank level gauging system. So our main topic is the ballast water treatment system. So I'll just wait. I'll give you the ballast water treatment system after break. So I will give you the information about new technologies for chasing the IMO exhaust gas regulations. That is the DNOx and SCR system. Okay, let me start. This picture is our new provinces, that is new integrated provinces. It's located in Busan. I know you people are very familiar with Korea, so this Busan area is just half an hour to Geoje Island. That's Daewoo and Samsung. They're close to each other. So this factory actually is 6 times bigger than our existing factory, and investment capital is $50 million. That's a lot. So it means, we are not just company just disappeared, a couple of years. We want to give you that long support. So just trust us and trust BPCO, sir. And the annual production capacity for 500-ton two sets, that's the 3,500 units. It means over 10 units per day. So we are preparing the time when IMO regulation come into the force. So we are ready to go. So if you are interested in that, we will give you that the short delivery and guarantee consumer. In this integrated promises, we do it all ourselves. We have R&D and control management, marketing, and production. It will be done in our factory. And we also fabricate all components. That we are filter and UV system, we manufacture the UV lamp. This is our existing UV lamp manufacture line. So we will transfer to that on our new factory, but we'll make the bigger and very systematically automatic production line. We make the filter element. So we make the filter element, the filter chamber, body, so we make them all. That's our feature that compared to our competitors. Competitors, they, for example, they buy the UV chamber, the subcontractor, and your filters and UV chamber, they all from the subcontractors. So, quality control and delivery control is not easy, but we do ourselves. And the business field, this aircraft carrier, we don't actually supply aircraft carrier, but we supply the instruments to Navy. It was our main part, we supply that, and we developed green technology system. That's the main part, is the ballast water treatment system, and also we supply DINOX SCR and scrubber system. I know some of you are having a trouble with our instrument. That we actually used to get a supply from our subcontractors before, for example, MAS. But we do research, we do develop our own product that is a level 3000. So I hope you please try our new product. So we're willing to get your inquiry. And your ship is trading all over the world. So we having that effective customer service care. We have the network and doing the serving that prompter action for the after service and spare parts. This is our factory. I just told you that we are located in Busan area. So in the meantime, we having the factory in the Busan, Gimhae, R&D center, or split. We will be integrated next week. And we have office in Busan, Japan, China, Notre Dame, and California. In Europe, we have different countries and have an agent and service network. And we have a BPCO in Greece. So we are setting down our service network, service station with a spare parts warehouse with BPCO. And we also train 2 special engineers in Korea, but it's not that like a robot. We will have that human being to give it the support, the BPCO. And also we have a Middle East and America service network. And Asia, also we are located in Asia, so service network. Okay, let's move to our another product. That's the DINOX SCR system. That's the exhaust gas treatment system. We've been leading company for 25 years in marine industry. We also developed and supplied the DINOX SCR system, land-based. In this know-how, the reference, the land-based DINOX SCR system for 15 years, we also supplied our SCR system in marine. For 15 years, we supply our SCR system land-based, more modernly that in California, Hawaii, and New York, because in the USA, they are more strict, tough regulation for that NOx emissions. So we have a joint venture company in California. The regulations is like that. In 2016, Tier 3 regulation will be coming to the first. Tier 3 regulation is NOx limit 80% should be replaced. So 80% of NOx should be replaced. The available NOx technologies, engine adjustment, water immersion, SAM-HAM-CAM, emission gas recirculation, this kind of technologies are available, but only SCL technologies can comply with the Tier 3 regulation. It can reduce up to 90%. It's a simple SCR, it means selective catalytic reduction. Just injection ammonia to the gas pipe, having a simple chemical reaction inside of the reactor with the catalyst, and after the simple chemical reaction and harmless nitrogen, water vapor emit to the atmosphere. That's the simple the technologies. For these technologies, we need a component. We supply whole system. The main component is the reactor with a catalyst, and urea pump station, urea control unit, and total control system. And it's simple operation, automatic operation, just press operation buttons. And the ship, as you know, you better than know me that there are engines, 4 or 5 engines. So we supply whole system with one urea tanks and one pump station in pumping up and distribute urea through distribution panel. And dosing unit, it control the urea amount and inject to the chamber and having a chemical reaction at the reactor and NOx analyzer analyzing the emission gas. You know that not enough space at the ship, so we cooperating with the shipyard and to put it in our reactors. So we supply our system more than 6 ships. So we have a certificate from DMV, ABS, and KR. This is our reference list as power plant and marine diesel engines. Okay, this is our other product, PASOX scrubber. I think you know that. It's just NOx emission control, NOx emission regulations. Now, in a month, 2015, at the ECA zone, there's limit 0.1 sulfur in the fuel, worldwide 2020. So you are very, think about that for the regulations. There are 3 options, MGO, LNG, scrubber. On these 3 solutions, there are positive and negative things. Okay, use low sulfur fuel, the CapEx is negligible, but operation investment cost will increase. And using that MGO, poor ignition will be happening. And another solution is that scrubber. With this scrubber system, just use the burning that HFO with that existing propulsion system, but you need to think about that space and back pressure. And payback time, if your ship is trading inside of the ECA zone, the payback time will be just less than a few years. LNG fuel vessel, also, the solutions, but you need to change the whole engines for that retrofit and infrastructure for the supply channels. Okay, our PASOX system, our scrubber system, is just a one-line system. It can replace the silencer put in. And we already done our pilot test with the 0.5 megawatt engine, and efficiency, it was reduced 99% of stocks. This is our system diagram. We have in the hybrid system, open mode and closed mode. But technically, this scrubber technology is very new technologies. So comparably to for the other competitors, the old pretty much same technologies we got. But our feature with our development is this reduced compact system. Normally that competitor, they have a jet entry and tower, pack tower system, but we having the one line system, so it can reduce up to 30%. So if you are very interested in our system, just send us your inquiry. I'll give you the questionnaire. Just please feed in the data as long as you can, then we give you the proper proposals. Okay, thank you very much. Thank you. So have a break? Okay, so we don't actually have a time, so we just continue to introduce our main topic, ballast water treatment system. So I will introduce our marketing manager, Mr. George.
Mic test. Yes, it's okay. Okay, my name is George Zhang. I'm marketing manager in PANASIA. It's my pleasure to speak in front of you guys. I hope that this conference will be a good opportunity to share idea about the application of ballast water treatment system. First of all, I would like to let you know the status of ballast water treatment system lure. Here. Okay, this page shows the status of IFO BWM convention. Currently, 43 states representing 32.54% of global tonnage ratified. And also, Italia and Argentina are likely to ratify it by the end of this year. So we are expecting all conditions will be met by the end of this next year, and the rule will come into force on the early of next 2016. Okay, the second rule is USCG. This rule already came into force in 2012. Following this rule, the ballast water treatment system should be installed on the vessels which are going to in U.S. port at the first dry docking after January 1st, 2014 or 2016. So here I would like to ask you something. Are you ready to install ballast water treatment system? If yes, when are you going to install it? Okay, so there are, I prepared some table I'd like to show you. Okay, following this expected schedule, ballast water treatment system should be installed on 80,000 vessels by 2012 or 20 or 21. It means that every year from the 2015, the average 12,000 to 14,000 vessels have to install ballast water treatment system as a retrofit. And also it means that you might be difficult to arrange the retrofit schedule. Let's see the repair yard. Okay, it shows the repair yard in the world which I can find out from Google. Total quantity is 369, but how many shipyards can do retrofit? Actually, I have no idea for that. So I just suppose that all those repair shipyards can do the retrofit job. So following the previous table, every year average 13,000 ships should be retrofitted for 5 years. It means that each repair shipyard has to do 35 retrofit works every year. I think it is going to be very tough schedule for every parties, like a ship owner and shipyard and the makers. So I'd like to ask you to consider and arrange the retrofit schedule in advance. If not, here we all have to wait for this job in the long line, just like to buy iPhone 6. So kindly check your dry docking schedule for all your vessels and make a retrofit schedule. Then you can ask us the pre-inspection with the 3D scanning as a free of charge from the early schedule of vessels. I will inform you of more detailed information how we can do retrofit works for you at the last chapter. Okay, here I would like to introduce our system a little bit briefly, because you have a lot of information for all kind of systems. Okay. It shows our systems line up. Now you can see 3 different generations. The first generation is for the small size of pump capacity, and generation 2 is for the medium size of capacity. Generation 3 is for the large size of pump capacity. Also, we already have a USCG AMS approval, and also we have a tax approval for X-Proof, G9, so G8, and flag stage approval, and other class type approvals. Here now you can see our reference list. Until now, we already made contract for 740 ships, and then now, until now, we already delivered and 434 ships. Okay, this is Chrome Petrol. As you know, our system is a filter plus UV type. It is consists of 4 simple components as filter unit, UV unit, and control panel, and UV power supply panel. Chrome Petrol is 100% physical treatment system. It means no need to neutralize the treated water. And also, because of simple configuration, using only 4 components, crews can operate it and do maintenance job very easily. Moreover, our components like a filter, UV unit, and UV lamp are produced by ourselves at our factory in Korea. So we can control everything differently with others. Maybe some competitors buy filter from this company and UV unit or lamp from another company like this. It is not good for them. Okay, so you don't need to be worried about the kind of quality problem and providing the after service and the spare parts later. Actually, these pictures is very confidential, but I brought it. Those things are our facilities to make a filter unit and the UV lamp and UV unit in our factories. Also, we have our patents here. Okay, I'd like to inform you more detailed things for our components one by one. This is a filter unit as a screen type filter. It is removing large organisms bigger than 50 micrometer as pre-treatment. It can prevent the part of sediment in ballast tanks. Also, it has, now you can see here, we have 4 layers mesh. This one is for main mesh, which is astelloy. For rest of 3 meshes for the protecting main mesh. It is made in stainless 316L. Also, we have automatic backflushing function in here, the suction scanner inside the filter is touching the surface and moving around, going up and down to remove sediment. Okay, I'm gonna show you some short animation, how to work the auto cleaning and maintenance of filter. Okay, there are pressure transmitter in inlet here and outlet. It measures the differential pressure between inlet and outlet. If the differential pressure reaches a certain point, it is operating automatically. Okay, for the maintenance, I told you it's very easy. Just to pull out the bolt and nuts and take out the stuff. And just the cleaning up using the air compressor or fresh water. After that, you can put it back. Yes. This is a UV unit. It is to disinfect microorganisms smaller than 50 micrometer. We are using the medium pressure UV light. Its lifetime is a minimum 4,000 working hours. It means that you can use it about 6 or 7 years without any replacement of lamp. It also has automatic cleaning wiper function. So I'm gonna show you. The animation here. Yes, the intensity transmitter is checking the UV lamp intensity. Then following that, the cleaning wiper is operating automatically. So for the maintenance, it is same way to filter. So very easy, just pull out the cover, take out the cover and replacement of UV lamp like this. Okay. Okay, this one is control panel and the UV power supply panel. Control panel has display of main data and it has a real-time monitor and logging data for 24 months as it is touch screen type. And also it has an alarm function. For the UV power supply panel, also it has alarm and shutdown function there. So until now, I'm gonna show you our system one by one. Now I'm gonna little comparison with other systems, okay? So this is issued by ABS, maybe in 2012, I'm not sure. Here they mentioned that the filtration and radiation, it doesn't affect on corrosion. And the time for killing are the UV type at the killing organisms at treatment. So no need to wait for some times, okay? Also, I told you before, we have only 4 simple components. By the way, the others, electrolysis and ozons, they have a lot of components. It means that for the crew, it is very difficult to handle on board if you have problems in there. And also, I found some information from the homepage of Severn Trent Denora, which can supply the system as electrolysis. I think it is side stream. Okay, they mentioned on their website a practical solution for operations in low salinity port. Okay, first method is add salinity. If it is failed, they mentioned that use UV type. It is only the option for that. It means that UV unit is not affected by the salinity and the temperature of seawater. So let's say our system is as 3 words: simple, safe, easy. Simple means from the seawater, filter first, then UV unit, and go to the ballast tank. And when discharged, the water from the ballast tank go to the UV unit and go through directly to the sea. And for the easy things, I told you before, we have easy maintenance and easy control and easy installations. For the safety, it is very important for you. As I told you, our system is 100% physical things, so there is no explosive gas and no toxic gas and no corrosion. Okay, this is main point of today. So I have met a lot of clients, of course, Korea and overseas. So yes, ship owner every time ask about this kind of 6 kind of questions. So I think it is kind of prejudice for the UV type. So for here, I'm gonna change your concept. Yeah, I'd like to give some tip for the understanding of our system. Okay, the number 1 question is UV power consumption is high. Yes, UV power consumption is UV power consumption is high? Yes, the power consumption for the big capacity pump for Glow and Petrol generation 1, at that time, the power consumption was higher than others. But now we already have generation 3. So we reduced the power consumption almost 45%, also to reduce the footprint together as 45%. Let's see here. So for the small capacity from 150 to 750, there is no big difference with the other systems for the power consumption. But here, from the 10,000 to 3,000 for the big capacity, we already same. There is no big difference here. Also, of course, we have filter unit. Maybe there is some power consumption need for the pressure drop, but I just put the information based on the power consumption of the main treatment. Okay, this one is I made some table for the operating cost. So most owners think about the FO used daily for our system, but approximately FO used per day is about 20 tons for ML tanker and 50 tons of VLCC, which means the owners spend about 8,750 to 21,875 every day. But ballast water treatment system is not used daily, as you know. Ballasting is used only in the port, so compared to other systems, you will only need to spend about, okay, this number a little bit was wrong, but more per years. So please see the table. I prepared 3 type of capacity. First one is just 1,500, and the second one is 2,000, and third one is 3,000. Okay. I just assumed 10 times for the ballasting per year. It means the operating hours about 480 hours for 1,500 tons. In this case, I calculated using this kind of power consumption that I got the result. FO price per year like this. Okay, there is no big difference. And also for the 2,000s, no big difference. For the 3,000 also, there is no big difference. Also, I prepared about the maintenance cost. It is to be known the maintenance cost for UV must be expensive since there are many UV lamps installed in UV chamber. However, Panasia produced the main components, UV lamp and filter, so the price and quality delivery service is different among other manufacturers. Okay. Okay, for example, this is 1,500 tons here. So for the 3,000 tons, it means we need 128 quantity of UV lamp. So each price is 700 USD per one UV lamp. So total cost is about 6,600. So maintenance cost is per year about $10,756. What about the electrolysis? For the 3,000, they have six kind of electrode chamber. Even if their lifetime is 6,000 working hours, but each price is extremely higher than UV lamp. So total maybe about $150,000. It means maintenance cost per year could be $12,000. Okay, third question is about UV does not disinfect well in dirty water. UV sterilizer is known and proven technology for treating water for over 100 years. The method of UV is exposing organisms and destroying DNA. So there are misunderstanding that UV is not effective in dirty water. IMO well understand this matter, so there are some clouds about TSS. TSS is here, total suspended solid. So IMO mentioned that TSS standard is like this. So Vietnam, in case of Vietnam Mekong River, in the dry season, it could be 50 milligram per liter. So I brought some study of water quantity. They mentioned that they mentioned that about the water quantity in the Mekong River. Okay, here. So IMO mentioned that the TSS is 50 milligram per liter for the fresh water. But in this case, according to this report, this is very bad conditions. So our engineer or our R&D guys went to the Yangtze River in China. As you know, the Yangtze River is one of the dirtiest water in the world. So we checked that. We got this kind of the result. Even if it is very dirty, the average is just 20 or 80. It means here condition is good. So you don't need to worry about the dirty water. It looks like dirty, but it is not really dirty. Anyhow, we already made some tests. Of course, it is our self-test. It is not official things. But for here, we got some result here. So here TSS. Okay, our UV power lamp has 3 steps power. First one is 100% power, and 90% power, and 75% power. So following this table, TSS, even if there is a 550 milligram per liter, there are a lot extremely dirty. Our system remove everything using the power, 100% power. So also for the transmitters, TSS is like a turbidity. These transmitters also important for the UV units. So, oh, sorry, we already did the test. But even if 60% of transmitters are customs, there is no problem. So, as I told you, this is unofficial things. So we are going to prove this is true through the USCG approval test. Okay. Number 4 question is UV treat twice during ballasting and deballasting. So many clients think about things that, okay, UV is, because power is very low, so maybe they're doing two treatment for the sterilizing. But here, RWO, this is manufactured by the electrolysis by Germany company. But electrolysis, maybe almost the guys know the electrolysis and ozone, there is no two treatment, only one treatment during the ballasting. But here I can read it for you. Therefore, prior to discharge, the ballast water is treated a second time by the electrolysis disinfection cell to ensure that the performance standard D2 as set by the IMO is met. And also Samsung Shipyard, Neopurimer, they also providing filtration electrolysis. They also mentioned that the major change is the Neopurimer system is additional disinfection process at the ballasting. The treatment at the ballasting ensures that complete destruction of any organisms, including something bacteria. So the reason we made our system as two treatments type, it means because of the reason is very simple. IMO mentioned that on their rule, UV type should be treated as two treatment because at that time, IMO guys thought about that. UV power will be weak because it is physical treatment system. That's why at that time, IMO guys put that kind of two treatment things. So we did test to get the approval. IMO, we did two treatment. So as you see, the electrolysis is also following this kind of two treatment system. It means later then, all system will be two treatment type. Okay, by one is yes, it is very critical things. Many of them you guys here heard about that. You already heard about that. Some rumor about the UV lights cannot. UV has a rigorous after treatment, but we already did with the NLP, it's Korean lab, and also Komari. So the result was perfect. There is no rigorous. So it means you don't no need to worry about this kind of rigorous. Okay, last one is filter clogging. As you see here, there are 50 ballast water treatment system maker, and 86% are using filter and cyclone as pre-treatment system. It means that this kind of thing is already mentioned. The IMO standard, there is a sediment control. That's why everybody, almost the manufacturer, has filters. Okay. As probably already know, candle type filter has clogging problem in the early market, so now some manufacturer changes their filter to the screen time. We PANASIA have already adopted this kind of screen filter, so I'm gonna give you some comparison table in the next page. Okay, the most important features with filter, first one is filtering, and second one is backflushing. Clogging has intimate relation with backflushing. So below is showing the two most used filters in the market. This one is filter screen filter. screen type filter. It has only one filter element in filter body, and suction scanner will clean the whole filter elements, as you see the animation before. So second one is other makers like a candle type filter. It has dozens of filter elements inside the filter, and suction scanner is doing from top here, bottom here. Okay, what is different? Okay. So for 1,000 tons, one set. Of course, the candle type has many kind of the filters, so the efficiency is a little bit higher than the screen filter. But here, water waste compared to other makers does more operating time. So operating time will be longer than other hours, and then also, how can I say, they have many the pressure drop of the vessels. So after so I prepared two appendix. Appendix 1 is a stripping issue. Last time when I was in Singapore, some clients asked about this kind of stripping issue. What are you going to do for this? So fortunately, according to MEPC 67 draft report, the sampling is not needed when stripping operation. So from now on, you don't need to worry about this kind of stripping issue, because the stripping water is very small quantity, so no meaning to take a sample and do the test. Okay, second one is our USCG type approval schedule. Many clients asking about this, so I prepared. So following this one, okay, we already made a contract with the DNV through the Golden Bear Independent Lab in San Francisco. So we are gonna start test from the early of next year. Then finally, we will get the final approval by the end of 2016. Okay, last one is a case study for the retrofit. Okay, this is what we can do. So our service scope is like we have 4 cases. So first case is we can just supply our system. It means you have to prepare installation materials and installation work on engineering things you have to prepare. But if you don't like this, you can ask case 2. Okay, PANASIA, you can supply equipment and engineering. Yes, we can. So for the case 3, you can also provide with installation materials. And last one is we can do all together at once by ourselves. This is a kind of whole schedule from A to G for the installation. There are 2 ways to retrofit. First one is installation in dry dock, and second one is installation on voyage. As you see here, total time for installation from A to G, it takes about 4 or 5 months. Okay, before contract here, we are gonna do our pre-inspection using the 3D scanning to find out our space. Then after we provide our offers, and then we make contract with owners. After that, we are starting detailed drawing work for installation with the plan approval. After finishing everything, we need 2 or 3 months for our production. So after that, your vessel come into the port here. We will put our all materials on your vessel, then starting the installation. So here is in the dry docking, we need only 10 days for the installation. For the on voyage, we need 12 days because about 12 days or 14 days because the schedule is not, how can I say, not fixed. So many unexpected situation maybe, so it's a little bit longer than the first installation things. So this is our reference. So first time I saw you reference list, there are mentioned we already contract for 12 vessels for the retrofit. We already did 9 retrofit works. So this is one of the example. So this installation we did during the dry docking. The ship type is a container vessel, the owner CPO Penn Germany. At that time we supplied our system and engineering and materials. The installation work was by the shipyard in China, HRDD shipyard. So owner hired the contract with this shipyard and the installation did by them. Okay. Of course, supervision we provide together with commissioning. This is case for Don Voyage. This ship type is 34K bulk carrier. Owner is Transship in Ukraine. Okay, here. Okay. At that time, we supply our system, of course. Then we provided the engineering and service. But in this case, the installation work by the crews. So at that time, we only supplied one supervisor, and with the crews, we done this job in 14 days only for the installation. Okay, I brought a little bit long animation than others. Yeah, this animation is for the retrofit, how we do before, and also you can see small picture here or here. It is for the CPO pen we did before, so you can see actual picture in here. So after onboard survey and the contract, then using the 3D. Okay, this is onboard survey. We are checking the space using the 3D laser scanning. And we find out some space like this. Cable tray here. So using the 3D file, we can make the drawing. So we remove this existing pipe and install the new pipe for our system. Our material is prepared on the dry dock, and then that's will come into port. Our materials will be on board immediately. Put our system into engine room like this picture. Animation has a lot of space, but actually not like this. Very complicated to move our materials. before installation like this, after installation like this. So after finishing installation, we are gonna test some kind of hydraulic test for the leakage. So this is for the engine room installation, but this is for the in case of the MR tanker, there is no pump room, no small space in engine room, so we can use machine case. Sometimes we can call it container box, but it is different structures. So we are using this structure. We install our system very simply. This is actual work in the SPP shipyard. Also, we have many reference for kind of this concept with the Hyundai Mipo shipyard. And then after commissioning and class inspection, if there is no problem, she will be delivered. With door pins like this. Okay, this is all I prepared. Thank you for your listening. Thank you very much.
So we shall have a break and we shall continue in 5 minutes, okay?